Hi everyone. Today I'm interviewing a friend, Jim Anderson, current CEO of Lattice Semiconductor, an FPGA company you may not have heard of. I know Jim back from his days at AMD when he was in charge of the client compute and graphics group there, and he was instrumental as the company launched the first generation Ryzen products. In fact, Jim and I have spent a couple of dinners together waxing lyrical about the future of compute. Now, I've known he's been CEO of Lattice for a few years, just trying to find the right time to get him on the channel for an interview, him to speak about not only Lattice and the new culture he's installing at the company, but what makes him move from CPUs at AMD to FPGAs at Lattice, and he's also spent time as an architect with Titanium and Xeon at Intel, and also network processors at LSI. He's been around a bit, and I wanted to find out why. What's your minimum specification? Sounds good. Jim, good to see you. It's been years.
It
How have
has
you
been
been?
years, Ian. Yeah, very good, very good. Great to see you again. I think it's been about 3 years, actually.
Yeah,
You look good though. You don't look a day over the last time I saw you.
you, you too, man. I mean, it's
Thanks.
I do remember being in the heart of Italy with some AMD launches in your previous career, obviously. Yeah, but now you've been 3 years CEO of Lattice. That's quite a step up, isn't it? From being SVP of client and was it client computing and graphics business segment
Yeah,
at
it was
AMD
Computing and Graphics Business Group. Yeah, yep.
to CEO at Lattice. I mean, I remember reading the headline. Congratulated you on social media, but didn't reach out personally. I was thinking, what made you make the jump, if you don't mind me asking?
Yeah, sure. Well, first of all, I loved it at AMD. Right, I was super happy there. First of all, I love the people at AMD. Great people, really innovative, very determined. And of course, Ian, I'm a product guy, so I always have passion about the product, right? And in particular, the product we were launching that day back in Italy, I was always super excited about. So I love the products. But when Lattice reached out to me, it was kind of hard to pass up the opportunity because Lattice is a company that's actually one of the original founding FPGA companies from the early 80s. So there were a few FPGA companies founded in the early 80s, one of which is Lattice. So it's a company that's been around for about 40 years. It's got a great history of innovation and kind of a unique place that it innovates. It innovates around small, really power efficient FPGAs, and those devices go into all sorts of applications across many different markets. And so it was a great company. And I felt like if I joined Lattice, that I could help it get on a stronger path moving forward, help it build products more quickly. And so that's kind of what attracted me to Lattice. And look, last 3 years have been a lot of fun. We've completely rebuilt the product line at Lattice. We're on a great trajectory. And actually, I'm even more excited about the years to come at Lattice. We got some really, really great products on the roadmap.
I think a few days before we're filming this, you had your latest quarterly financial announcements, revenues up, product lines coming into view. The thing is, when we speak about FPGAs, especially to my audience is very CPU, GPU focused. But FPGAs have been around, as you say, 40 years.
40
And
years, yeah.
whenever we speak about FPGAs, we always speak about the big names in the industry, the Xilinxes, the Alteras, the ones that make the big chips. Now, obviously, Altera is part of Intel now. But
Yeah.
can you talk about how Lattice positions itself in the market compared to those big names? And
Yeah.
can you put a nod to why that matters where Lattice is?
Yeah, absolutely. And, first of all, let me point out that if you look at unit volume size, actually Lattice is the highest unit volume manufacturer of FPGAs. So we're the biggest by unit volume, I'll point out, right? But yeah, where we specialize is, as I mentioned, in small size, power efficient, very, very easy to use FPGAs. And because they're really power efficient and they're small size, they can go into just all sorts of different applications that a really large FPGA just can't go in, right? So either from a physical space constraint or a power constraint, our devices can reach all sorts of applications that our competitors can't. And so you'll find us in, industrial, all sorts of industrial IoT applications, industrial automation and robotics. You'll find us in communications, computing, consumer devices, automotive electronics. And so we really specialize in the small power efficient part of the market. Those two competitors that you mentioned, which are traditional competitors, they really focus on the, as you said, the very, very large, very high power, complex FPGAs. We focus on the small size, power efficient. And there's, Ian, you would be amazed at the number of applications we go into. Actually, whenever I meet with a new customer, I'm always, amazed at some, new, innovative, crazy application they're using our chips in. And actually, just to give you a sense of the size, so this is on the end of a tweezers here. This is one of our products called the ICE. I think we sent you a few of these, right?
Okay. Let's see if I can get the camera to focus in. I don't think I can. It's too small.
Yeah, so it's on the. I'm showing it on the end of the tweezers, right? So this is I think it's about 1.4 millimeters on a side or something like that. This is one of our smaller devices. Obviously, we make some bigger devices as well, but devices like this size can go into applications that other chips can't, right? Again, by whether there's either size or power constraints. Hey, by the way, Ian, since you mentioned the last time we met, so when we met 3 years ago, this was the chip that we were talking about, right? So I've got this with me. Oh, you've got it too. All right. So this is the Threadripper chip from AMD, and yeah, that's to give you the comparison in size. So I've now moved to the total other end of the spectrum, right? So I'm working on myself and the Lattice team are really innovating at the other end of the spectrum, small, power efficient, easy to use. And like I said, important to lots of different applications.
I think power efficiency is now that sort of permeating aspect of all silicon these days. Whether you are on the high end or whether you are on the low end. I mean, speaking about 1,000 square millimeters of silicon down to 0.01 square millimeters of silicon, those tiny packages. Your PR team sent that strip to me. I was like, what is this? Why have they sent me a bit of plastic? I had to get, the Zoom macro on my smartphone to zoom in. And even then I still can't read what's printed on it. This is crazy.
When I first started, looking more closely at Lattice before I joined, that was one of the things that I found really fascinating. Is I spent a lot of my career working at the other end of the spectrum on big, high performance CPUs and DSPs and things like that. And to work at the other end of the spectrum on the smaller size, power efficient, and FPGAs as well. I just thought it was pretty fascinating. So anyway, yeah, good. Well, I'm glad you got the samples. That's good.
I'm going to sprinkle it on my cereal, I think, and and I'll turn it into hundreds and thousands.
But, there you go.
You mentioned your history, and I'd be remiss if I said I didn't actually look at your kind of history before we arranged this interview. Sure. But going through, along with in charge of client division with AMD when Ryzen was announced, you've been a CPU architect at Intel, strategic planning and marketing on networking silicon at LSI, masters in EE from MIT. What is it that ends up drawing you from architecture to planning to networking to processors and graphics, and now to Lattice? It's do you get an kind of like an itchy bum that you need to keep moving around, or?
Yeah, actually, the way you said that, it makes it sound like I can't hold down a job, right? So, so maybe it's just I can't
master of skills. Master of skills.
Yeah. So, so I would say the common thread through my career is always that I've worked in the semiconductor industry. But you're right, I've worked in a number of different functions. I started as a CPU architect at Intel, working on Xeon and Itanium chips, but I've worked on multi-core DSP chips, really complicated network processors used in communications. Lots of ASICs, CPUs for client devices, graphics, and now FPGAs. So, but the common thread is always within the semiconductor industry. I think for me, the semi industry is really exciting because it's the foundational layer of the entire tech industry, right? It is the fundamental substrate of the rest of the industry, and it's pervasive in our lives, right? It's used anytime you touch an electronic device, you're touching the semiconductor industry in some way. And so I'm just fascinated by the whole spectrum of devices built in the semi industry. And so now the opportunity to work on FPGAs at Lattice, in particular, the small, really power efficient ones are, it's just a great opportunity. And so, yeah, it's just semi industry is great, and I like all parts of it. So, yeah.
Well, on the context of FPGAs, I mean, on a holistic level, whenever I seem to mention them in my work, I always get comments of, well, why don't they just build an ASIC, right? So can you kind of explain why Lattice's customers, or really anyone that uses an FPGA, chooses to do so over either building their own dedicated hardware or simply implementing a software solution?
Yeah, sure. And there's both technical reasons and there's also economic reasons too, right? So if we start with the technical reasons, a lot of times a customer, our customers are trying to innovate on their system designs. They're trying to figure out, hey, how do I add some new features, new capabilities that differentiate us in the marketplace? And a lot of times an FPGA, which is incredibly customizable and adaptable, right? That can be a key part of the system that allows the customer to really customize and adapt their system. And then one of the benefits of the FPGA is not just that you can customize it for exactly what you need versus, say, a standard product, but you can reprogram it over the lifetime of the system. And so, let's say, as your market needs change, or as you want to incorporate new features, or actually, we have a lot of customers that run artificial intelligence algorithms on our FPGAs, and those algorithms are constantly evolving. And so the fact that they can just reprogram the FPGA as their next evolution of the AI algorithm changes, that's a big benefit. It provides future proofing for the platform, and so that's a big reason why customers design in FPGAs in general, us in particular. Another reason is that you mentioned ASICs. If you're going to build a truly, a custom chip for your application, that's minimum. That's 18 to 24 months to go build that chip, right? From kind of initial architectural concept to when you have something that's production ready. And your needs could have easily changed over those 2 years that it takes to develop that chip. Whereas with an FPGA, you customize it right away for exactly what you need. If the needs change over that 1 to 2 years, no problem. You just reprogram the thing, right? So those are some of the technical reasons. And because our chips are really power efficient and size optimized, a lot of times there's not a big advantage to, say, a custom chip in terms of power or cost. And then, kind of on the economic side, if you look at the expense of doing, for instance, a fully custom chip today, that expense has escalated incredibly over the last 20 plus years I've been in the industry. It used to be inexpensive to create your own custom chip. It's way more expensive now, both in terms of development effort, mass costs, etc. And so it's really seldom that it actually makes economic sense, especially with the type of FPGAs we have and the cost points that we can hit. There's really no economic benefit as well. So for all those reasons, if you look at the history of the FPGA industry, it's grown as fast as the semiconductor industry in total, or faster in many years, in many cases. And so that's why you see over the past 40 years, FPGAs continuing to grow, and that market being very healthy as customers continue to adopt that in all sorts of applications.
So, for context, to bring it to the readers and the audience right now, it's where can most end users expect to find a Lattice FPGA in their daily lives today, do you reckon?
Yeah, I think it's hard if you're using any electronic device, it would be hard to not touch a Lattice device somehow during your daily life, right? Either directly or maybe indirectly through, for instance, a data center or some of the industrial stuff that we do. For instance, in servers now, if you look in servers, that are either enterprise class servers or servers that are in big hyperscale data centers. And obviously end users are accessing data in data centers, big hyperscale data centers all the time. You would find a Lattice chip in almost every server that ships today. Way over 80% of servers have a Lattice chip, at least one of them, that's doing control and management of the platform and security as well. You're now starting to find Lattice devices in client computing devices, where we're providing a number of kind of new functionalities. Communications infrastructure, so either wireline or wireless infrastructure like 5G infrastructure, lots of Lattice devices used there. All sorts of consumer electronics, high-end audio systems, home automation systems, automotive electronics. I'm trying to make sure I ran through the whole list here, but I think that gives you a sense of, we have over 9,000 customers, and actually, if you look at over the last 4 years, we've shipped about 1 billion devices. So think about that, about 1 billion Lattice chips in all sorts of applications. So you'd find us all over the place.
Well, if it's these tiny ones, and that's then what, a couple of pounds a kilo for 1 billion.
We do have some bigger ones than this too, right?
Yeah. It's touching on the server space. I recently spoke to Isam Ilashmawi, one of your product and marketing guys, VP, I think. He explained about the server market, how Lattice used to be in, say, 20% of servers, and now, as you say, 80% of servers. And reviewing this stuff, I kind of always saw the Lattice chip in there, but it never really clicked the volume of how many Lattice chips there. And I think Isam said that the attach rate is more than one Lattice FPGA per server moving into next generations.
Yeah.
And I know you just touched on a few of the brief topics there, but why exactly are we seeing Lattice in so many servers today that we weren't 5 years ago, say? What exactly are they doing in there?
Yeah, great question, and it's definitely been a big growth area for us. Our position in servers has grown considerably over the last few years, and we expect it to continue to grow. As Isam said, if you go back 2 or 3 years, about 20% of servers shipped with a Lattice piece of silicon, and a few years ago, doing fairly more basic tasks of sort of power management or basic control functions on the server platform. Now, if you zoom forward to today, over 80% of servers today in the latest generation that's in volume ship with a Lattice piece of silicon, doing more control and management of the server platform. And then moving forward, we're doing more security functionality as well. It used to be that years ago, people were just worried about security at more of the software layer, but now, there's concern of security all the way down to the hardware platform. And so we have specific Lattice devices that are designed to provide what's called platform security or platform firmware resilience. And so what our devices do is they go to and check to make sure, for instance, as your server is booting up, that the hardware itself hasn't been corrupted, or also the firmware hasn't been corrupted. So it will look at the firmware version before the system starts up, verify that it's the correct firmware version, that nobody's corrupted that, loaded the wrong piece of firmware. And then if it detects the wrong piece of firmware, because we have a golden copy stored within the solid state memory within the chip, it will actually swap and repair that firmware. And so that's just one example of kind of the new capabilities that we're bringing to a server. But yeah, if you look at today's servers, over 80% ship with Lattice silicon. In the next generation, that's just starting to ramp, what we call our attach rate will actually start to exceed 1x, meaning there's server platforms where multiple Lattice chips are used. And so we'll actually be shipping more chips into the server market than the total number of servers that are shipped. And our ASPs continue to grow up because we continue to bring more value to each server generation. And so this has been a great growth area for us. We, based on the multi-generational discussions we're having with our customers, we expect it to continue to be a good growth area. But by the way, I should mention, because I figured you might ask, based on my history, we're CPU agnostic. So Lattice, Yeah, we support both Intel platforms and AMD platforms. And in fact, we support ARM-based servers too. And that's actually an advantage for our customers. That's important that we're able to service all architectures. So we're totally agnostic.
I was going to ask, do you make very specific versions of your FPGAs for AMD, for Intel, for Ampere, or do they just take the ones off the shelf and optimize it how they want?
That's exactly right. The latter. That's the beauty of it is it's one FPGA that can be customized for each server OEM or each server customer because they want to. Our server customers are putting their own customization into the FPGA, and that helps them customize or differentiate their platform. But the beauty is we can use a single device to service that.
So changing gears a bit, I mean, I've been listening in on a couple of the recent Lattice financial calls, and it's interesting to hear you mention repeatedly this sort of culture shift internally around 2018, which just happens to be about the same time you joined the company, right? So can you kind of
It might be
explain?
it might not be a coincidence. Yeah.
Okay, can you explain what was in place and how you've adjusted Lattice and what that sort of culture shift looks like? I think you alluded to aligning the product roadmap earlier, but does it go beyond that?
Yeah, I think it goes beyond that. I think there has been a pretty significant cultural change at Lattice over the last few years. When I joined in September of 18, shortly after that, I brought on a new leadership team, went and recruited for all the kind of key functions like engineering and sales and marketing and supply chain deep industry veterans. So people that have been in the FPGA industry for not like a few years, but decades, multiple decades of experience. So we really rebuilt the leadership team with industry experts. And then, yeah, we did make a pretty big cultural shift at the company. I will say there were a couple cultural attributes that Lattice has always had that we definitely have encouraged. We've maintained those cultural attributes and we've encouraged that. Things like Lattice has always been very customer centric. And in fact, if you ask our customers, they'll tell you one of the reasons they love working with Lattice is because we've always been very attuned to our customers and very customer centric. And so we're definitely continuing to encourage that. Also, Lattice is a really collaborative place, collaborative internally. The groups work really well together, but we also collaborate really well with our customers. So we're encouraging those cultural attributes. But we did encourage or bring some new attributes. One of them is around speed and agility, which I feel like in the tech industry is a really important, can become a really important competitive advantage. I think that speed and agility matter a lot more than the size of the company or the size of the resources. I think your ability to go fast, get products to market fast, to adapt quickly is absolutely a competitive advantage. And so that's something we've really encouraged since day one, since I've joined. And I think you can see that play out in our product roadmap. If you look at the number of new products we brought out over, say, the last 2 years versus you go back 3 to 5 years in Lattice's history, we've tripled the rate of new products that we're bringing to market. So our cadence is 3 times faster than it used to be. And so that's great for our customers. They love it because they've got new, fresh products coming out all the time from Lattice. And so I think that's a marker of that cultural shift towards more speed and agility. And then the other one I would say that we really encouraged was innovation. We always say innovation. Everybody says that, but I would say it's really being bold about the innovative steps we're willing to take. Right, being much more bold about future innovation that we're driving. And so I think that's something we've really been encouraging the team to do is be much more bold in terms of their thoughts about where we drive the technology and the product roadmap. So yeah, the cultural shift has been a big part, I think, of the progress that we made at Lattice. But the other piece that I would say that we sort of mentioned early on, and like I said, I'm a product guy. At the end of the day, the customers look. It's the thing they care most about is our products. And so the other thing we did right away in the first 6 months after I joined is we totally rebuilt the product roadmap. and rebuilt it for not just the next year or two, but the next 5 plus years. So completely rebuilt, really jacked up the where we were headed in terms of the performance and the capabilities and the features. And so that rebuilt product roadmap, we're now really starting to see the benefits of that, in this year and in the years to come. So that was the other big change too.
It's I did want to talk about product roadmaps because you've kind of been slowly announcing how you've realigned your products over the last few months. As you said, going from that, maybe one or two products a year, very linear cadence, into scaling out. I think you have the Nexus product line, and soon to come is the Avant product line, and then multiple derivatives of that. And you've also said this also helps, increase potential addressable markets by double, from 3 billion to 6 billion, I think the numbers were. But aside from, just raw revenue dollars, what's the goal here? How does an FPGA innovate? How does an FPGA company innovate in a space where, perhaps all the products your customers need are already available? Is it more customer demand, or is it more pathfinding, or?
Yeah, first of all, it's always customer centric. Our innovation, we always say this inside Lattice, our innovation is always customer centric and market application centric, right? So all the innovation that we're doing is to try to solve a customer problem or enable a new application. That's really what our innovation is directed at. And we did make a big change over the last 2 to 3 years in how we do that innovation. From a product roadmap perspective, we used to be very serial in how we built products. We'd sort of build one product, and then we'd with one architecture, and then the next product would have a new architecture, and we were very kind of sequential. And what we've done now is really step back, and what we call it is taking a platform approach, both from the hardware and the software perspective, and designed the platform, the FPGA platform, from the very beginning with in mind that we would build multiple derivatives and also versions of that FPGA platform that were customized around, or I should say, optimized around particular applications, or customer needs. And so that platform approach has allowed us to dramatically speed up the number of new products that we can bring to market, and then has allowed us to do new products that are more optimized for particular applications, right? And actually, I mentioned just a few minutes ago, one example of that would be security. So we're now developing FPGAs that are kind of uniquely optimized for doing platform security. The other examples would be FPGAs that are more optimized for doing artificial intelligence processing at the edge of the network, so inference processing in edge applications. And so that platform approach has helped us both increase the number of products, but also helped us really tune our products for the particular applications, the big growth applications or the big customer needs that we see.
Does optimization in that sense always mean, well, we take some of the logic gates away and building, say, a hardened crypto accelerator or a hardened AI accelerator rather than just letting it be free logic gates? Is that essentially what these optimizations are, or does it go beyond that?
Yeah, it can be that, but it also can be we may tune the FPGA fabric architecture or the implementation itself to be a little bit more better aligned to a particular application or need. So it can be a variety of different techniques that we use.
And that's through profiling customer workflows. So you obviously get together with customers to understand what they're doing.
Exactly. We spend a lot of time with our customers making sure we understand their needs, not just for the next 12 months, but for the next 3 plus years. And then mapping those customer needs or application needs back to the particular FPGA architecture.
You mentioned earlier about client computing. Now, I've gone through some of the numbers, and it looks like Lattice's revenue for client has kind of decreased over the last few years. But you're very much in the sense of promoting FPGAs to help with AI accelerated, say, camera analysis, people's webcams on devices, that sort of thing. Where exactly are we expecting to see Lattice in client computing in that regard?
Yeah, so first of all, client computing has been a growth area for us over the last few years. You might be looking at the wrong segment of our revenue.
That's probably true.
Yeah, our client computing falls within our computing and communications segment, and that segment has been growing really well. It grew double digits last year. It grew, another 15% year over year in the most recent quarter. So, and client computing's been a big contributor to that. We had a couple. There were a couple new significant customer platforms that began ramping into production last year, and then are ramping into full production this year. And then we're engaged with a number of OEMs on new client computing platforms. And by the way, when we say client computing, we're talking about basically PCs and tablets, those type of devices, right? But some of the interesting applications that we're getting used in are things like, artificial intelligence. But the usage model is, for instance, let's say I'm looking at my laptop, I'm doing work, but let's say I turn away and I look away, and maybe I'm having a conversation with somebody for a few minutes, and I'm not looking at the laptop. So our device will be analyzing the video signal. It will detect that you're still in front of the laptop, but you've looked away. It will detect that using AI algorithms, and then the laptop screen will dim to save the battery power. And then as soon as you look back, it'll bring the screen back up. And that may seem like not a big deal, but when you start to add up the power savings, the screen on the laptop burns a tremendous amount of power. If you save all of that battery life over the course of a full day, right, you can save quite a bit of or drive quite a bit of battery efficiency, much better battery usage, right? So that's one application example. Another thing that our devices, our FPGAs can do is watch that video signal. Let's say somebody comes up behind you and is shoulder surfing, looking over your shoulder at what you're working on. It can detect that somebody else has entered the frame, and then put a little red dot or whatever to notify you that, hey, somebody's behind you watching what you're doing. And there's a bunch of other examples as well. But we can do this because our devices are small and really power efficient. We can do this at incredibly low levels of power. And so these are some of the new features and capabilities that we're enabling in laptops moving forward, or PCs. And then another example would be security. Some of that same security that we talked about on server devices is also applicable to client devices. And so that's another potential application. But one of the things we really like about this market is, if you look at the server space, which we already talked about, we've done really well in really proliferating Lattice across the server space. But the great thing about the client computing market is, look, it's 20 times larger in terms of unit size, right? There's 20 clients sold for every one server. And so to us, that's just a huge TAM opportunity for, real greenfield opportunity to bring Lattice devices into that market and enable all new sorts of types of functionality and capability for end users.
So the demonstration about looking away and having people over your shoulder, there is one company who's demonstrated that today. That would be Intel. Are you working with Intel on that? Can I make that connection?
Well, what I would say is we would view Intel as, in the PC segment, as a strategic partner, a co-traveler. We would certainly work with them on enabling those type of experiences. What I will point out is that our devices can do that functionality at a ridiculously low power, right? So we have a big power efficiency advantage. And on a laptop device, Ian, as you know, right, power efficiency is a premium, right? And so our devices can do that at a level that I don't think anyone else in the industry can, right? And so, we would view Intel as a potential platform partner there, along with everybody else in the ecosystem.
That's a very crafty way of saying no. I love it. It makes me think, with that sort of topic, whether you would actually be working with the platform developer, or perhaps that would be more sort of an OEM enablement strategy. Maybe it's something that the OEM wants to do on top of a platform provided by a higher level partner?
We would work both with, we'd do two things. We'd work with directly with the OEM that's building the platform, right? We'd certainly be engaged with them. But then we'd also be working with the ecosystem as well to make sure that, our parts are interoperable and work with the rest of the ecosystem partners too. So we'd be doing both in parallel.
One of the things with FPGAs, I get a lot of feedback for is that they're just hard to develop for. You need to know how to use them before you use them, which sounds like the wrong way to learn how to code, I guess. What exactly is Lattice doing to kind of ease that transition for people who may understand software but are kind of new to the hardware game?
Yeah. Yeah, and this, this really goes off one of our main mantras at Lattice is to make, the use of our devices as easy as possible. And so this is something we've driven tremendous amount of improvement just over the last few years is to make the devices very easy to use. And not just for people that are familiar with FPGAs, but for developers that maybe have never used an FPGA in their entire career, right? Let's make it really easy to use. And so one of the big things that we've been doing over the last 2 to 3 years is developing what we call application specific software solution stacks. And so think about these as pre-built tools and libraries, kind of pre-built software libraries that a customer can just kind of take off the shelf and use that abstract out the complexity of an FPGA and allow the customer to use our devices at a level of abstraction that they're comfortable with, at a higher level of software abstraction. And so this is something we've been investing a tremendous amount of effort into, and we've built out a pretty significant portfolio of these application solution stacks. And they make it very easy for the customer to both adopt our devices into their system so they can get the innovation, they can get access to the innovation that we're driving and get that easily, but also get to market much more quickly. It also helps, even if a customer is familiar with FPGAs, it can help them switch from a competitor's FPGA to our FPGA, so it can ease that switching transition. And so we're building out a portfolio of these. We brought 4 of them to market to date. The first one that we developed was called SenseAI, and that's a software stack that's specifically for artificial intelligence, and actually for inference, doing inference processing, really especially in edge applications, whether those are consumer applications or industrial applications, really helping enable inference processing on our devices at the edge of the network. That was the first one. The second one was around embedded vision processing, enabling embedded vision processing on our devices. The third one, and we kind of touched on this earlier, was actually around security and platform hardware security, making it really easy to use our devices for doing hardware security. And then the fourth one, which we just brought out in May, it was around factory automation. And so this is making it easy to design Lattice devices for doing all sorts of industrial automation tasks as well as robotics. And so each one of these are, like I said, kind of a pre-built solution that the customer can take and use as is, or if they want to customize it, they can also customize it. But it's really lowered the barrier or reduced the effort necessary to design our devices into systems. And we're going to continue to build out. We've got additional software stacks on the roadmap. We'll continue to build out a wider portfolio here.
So, I mean, to explain it my way, that would be like having pre-compiled libraries that manage the FPGA, and all you do is you call the library and the functions therein, and it does it automatically.
Yeah, that'd be a good analogy, right? That'd be a good analogy for it. Yep.
Yeah. We spoke about communications and compute segment earlier, and it's not often we get the chance to direct users to think about what telecommunication companies need out of their silicon. It's kind of over here, people don't really think about it that much. But I've noticed that Lattice FPGAs are getting pickup inside telcos, especially as we move to 5G. What exactly are they using Lattice for in that environment?
Yeah, in fact, not just Lattice FPGAs, but the communications industry has a long history of using FPGAs in all sorts of not just wireless applications, which you're asking about, but wireline as well. You'll find FPGAs used in all sorts of different places in communications. In wireless applications, like the new 5G infrastructure that's being built out, where you'd find Lattice devices is primarily in the control plane, in either if you look at a base station, which is basically the processing at the bottom of the tower and then the antenna at the top of the tower, you'd find Lattice devices in the control plane, in the baseband unit at the bottom of the tower, but also in the radio heads that are at the top of the tower, which are transmitting the signals. And so we're doing, again, control and management of the system, power management of the system, and then some security functionality moving forward as well. And a lot of times the reason that in communications, especially wireless infrastructure, that FPGAs get used is we kind of think of, a lot of times we think of 5G as simplistically as, oh, that's just
Yep.
one monolithic standard worldwide. That's not the case, right? There's a basic, standard umbrella standard that exists, but each region has different frequency bands, different local customizations, and then also the 5G or any wireless standard is evolving over time as well. And a wireless infrastructure OEM may start to design a system before the for instance 5G standard is fully completed, right? And so they're building FPGAs in because they need the ability to customize for, let's say, different geographies, so they can reprogram the FPGA to adapt the system for different geographies with different unique requirements rather than building a dedicated hardware system for each geography. Or if the standard evolves over time and there's new capabilities or new functionality that they have to integrate into the system, they just reprogram the FPGA to adapt and include that new functionality in the system. So it's a combination of the flexibility as well as the adaptability and some future proofing. And so that's why you see FPGAs get used very often. And for 5G infrastructure, this has been a great growth area for us. We're still really early in the 5G build out worldwide. If you try to get a 5G signal, a true 5G signal, that there's a lot of build out that needs to happen, especially in North America and Europe, right? And so
Yeah.
we're still early in that. And, it'll be a great growth area for Lattice.
I think I read somewhere that Lattice. I mean, you mentioned the control plane in 5G, and there's also the compute plane where the yeah the telcos will use FPGAs initially there to do all the data compute and then kind of replace it with their own ASICs. Whereas with the control plane, they can't easily replace the FPGA in the center of it. So that kind of sustains your growth in that market, whereas maybe your competitors who deal with the big silicon won't. Is that fair to say?
Yeah, that's exactly right. So there's the data plane and the control plane, and we're usually designed into the control plane. In the data plane, where the data is flowing through, that's where the primary data stream is flowing through the system. There may be, when the system is initially launched, the large FPGAs used by our two traditional or designed by our two traditional competitors, those may get used initially in the initial systems, and they may get replaced by ASICs because those very large FPGAs are extremely high power and they're extremely expensive too. So they may get replaced by ASICs. Now, our FPGAs, which are on the control plane and are smaller, power efficient, generally don't get replaced by ASICs because there's not, for all the reasons we talked about earlier, there's just not a big economic reason to change them. Or from a technical standpoint, there's not a lot of power efficiency savings either.
With those large pieces of silicon from the main competitors, we see them, trying to aggressively on packaging and the latest process technology node. I assume these aren't made on some 7 nanometer process, are they? Otherwise, I wouldn't be able to see them, I think.
Well, I'm not sure the size would be that terribly different, actually, because one thing to keep in mind is, a lot of times on a device like this, it may be the size of the silicon may be I/O limited, right? And the I/O has both an analog and a digital component. The analog, as you know, actually doesn't scale very well with technology node. The digital part does, and so for when you get to a certain size, yeah, being on the latest bleeding technology node actually isn't that big of a benefit. And in a lot of cases, a bigger technology node is perfectly fine, and in some cases actually has some advantages, right? So, yeah, what we do with our devices is we're always picking the technology node that's really optimized for the size of device that we're developing and the customer and the customer needs that we're trying to hit and the time to market as well. And for a lot of cases, it just doesn't make any sense for us to be on the bleeding edge of the technology node. Now, it would be the opposite if we were building, let's say, big high performance CPUs like we did, like I did back at AMD. Yeah, it makes total sense to be on the bleeding edge, right? But for these type of devices, it just doesn't make sense.
To finish off, I kind of want to go full circle, and if you'll entertain me to speak about AMD again. I remember when we were having those discussions, I was always at a disadvantage because you knew what was coming down the pipe. But do you have any fond memories or special moments from your time there that you look back on and go, yeah, that went well, that did great?
Yeah, I mean, it's been 3 years now. The memory starts to get fuzzy, but yeah, I have a lot
But
of.
now you're not under NDA.
That's true, actually. That's a good point, Ian. Yeah, what I would say is, first of all, when I think back about my time at AMD, my really fond memories are about the people to begin with, right? I mean, I keep in contact a lot of people that I worked with at AMD who I consider really, really good friends, right? And it was just a great group of people, innovative, creative. AMD was always a really scrappy team. I loved that about the AMD people, really determined. And so that's always a fond memory. But if you mean in terms of, I think you probably mean more in terms of specific events. I mean, definitely, if I had to think about what events, or what things at AMD do I have great memories about. I mean, look, launching the first Ryzen chips was absolutely a great highlight to the time that I was at AMD. I mean, it was the computing and graphics business unit or client business unit that launched the first Zen-based devices, and of course, you were there for that launch, right? Then we launched them first into desktop, followed by mobile later. And so, the amount of work that the team put into that, how hard we worked, and the excitement and anticipation of just being able to finally bring Ryzen to market was really exciting. And then, the event that you mentioned at the very beginning, which was kind of the last event that I was at AMD, which was the Threadripper 2 launch. I loved that just because kind of always had a special place in my heart for Threadripper, because on that product line, we just would sort of throw out the rule book and just do whatever we could possibly, whatever the most extreme thing we could do, we would do on Threadripper. So I always had fun with that product line. But yeah, it was a great time. But the last 3 years at Lattice look fantastic. I feel like we've made a lot of progress over the last 3 years, rebuilt the product portfolio. But when I look forward, I'm much more excited about where we're headed over the next 3 to 5+ years. I think the next few years are much more exciting for the company than even the past 3 years have been. So really excited about where we're headed.
Do you have any project inside Lattice that is also the sort of throw the rule book out?
Well, it's possible. Stay tuned.
Stay tuned. That's awesome. Thank you, Jim, for your time. I know this has been a long time in the making, but glad to have you on the channel. And good luck with Lattice. I'll be reading your revenue reports over the next couple of years with great anticipation.
All right. Thanks, Ian. I really appreciate the time. Thanks so much. Thanks.
So many thanks to Jim and his team for their time. Really great chance to catch up. And as I said, it's worth taking a look at Lattice Semiconductor's financials over the next few quarters to see if Jim's plan is being put into action and it's actually benefiting the company in their revenue stream. My minimum specification here Those FPGAs, super tiny. Big CPUs are big. This market needs all kinds, and it's usually the small stuff we perhaps should pay more attention to. If you like this content, please don't forget to like and subscribe. We also have now a private Discord server, and if you want access to that, become a Patreon member and it'll instantly add you as long as your emails are linked. You can join the Patreon for as little as $1.50 a month, and it all goes back into helping the channel. Thank you for your support.